Welcome students, this is Chandan Singh Negi. Last sessions students we have discussed about the graph of 10x, and today we will draw the graph of cosec x. Right, like this is graph of this y is equal to cosec x, and we put the value of x and get the y. That is x is independent variables, or that means x-axis, and y is dependent variables, that is y is dependent on x, so that is y dependent variable, this is y-axis, and just put the value of y. We are just drawing the graph on the first quadrant and the fourth quadrant, like this one. See this one, cosec 0 is infinity, that means cosec 0 is 1 upon sine 0, and this is equal to 1 upon 0, 0. 1 upon 0 is called infinity. That is a undefined case of in mathematics, and we will understand about this undefined or infinity on limit and derivative. This is 0 is infinity, cosec 0, and cosec 30 degree, that means 5 by 6 is equal to 2, and this cosec 45 degree, this is pi by 4 is equal to 1.4 dot 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 to infinity, and cosec 60 degree, that means pi by 3 is equal to 2 upon root 3. This is equivalent to about this 1.15 dot dot to infinity, and cosec 90 is 1. See this one, the value of the cosec theta, that means cosec x, is decreasing. This is infinity, and then 2, then 1.4, and then 1.15, and then 1. And if you look this one, cosec axis and one y-axis, this is second quadrant, that is this is depend on y-axis, that second quadrant is positive, and then this after 90 degree the cosec value will be increasing. See, I get this values from the nets. This is like this one. If you look the closer to 0 degree, and the value of the cosec is rapidly growing, that means it tends to the infinity, and at 0 this is infinity, and but it is quite this is very near to 0 degree, that is like 0.001 degrees is 57,295 point to infinity. And if you look this one 0.00001, that will be, this is very in lakhs, and then again it very close to 0, then it will be tends to infinity. The value will be increase rapidly at near 0, and then the value will be decreases if you move toward the 90 degree. That is when cosec 5 degrees equal to, it is about the 11.4 dot dot to infinity, and the same thing on the left hand side. This cosec minus 30 degree, that is minus 2, and minus 45, this 5 by 4, this is minus 1.4 dot dot to infinity, and it has the value is increasing on the left hand side. See, the threshold point, that is the minimum point for us, there is, this is 1. Now check it, this is at here, this is infinity, and the y-axis is working as an asymptote. That means the graph of this cosec x never meet with y-axis, and the y-axis is working as an asymptote here. And now look, plot the point. This is pi by 6, that the value is 5 by 6, the value is, that is 2, this is 2, and that is 45 degree, the value is 1.4, it is about this one, and pi by 3, this value is 1.15, it is lesser than this one, and pi by 2, this is value is 1, this is 1, and this is rapidly increasing. If you draw this graph of this one, I have plotted these points earlier, and this one, the graph would like this one, this is asymptote, this is moving this one, and join these points by free hand, this one, and if you move further, and the same gap will be like this one, let's move to infinity. That means this is 5 by 2 and pi, sine pi, that is 0. This is 1 2 3 1 2 3 4. This is 1 2 3 4. Here this is the value, this pi. Again we draw this asymptote here. This is the asymptote, that is the asymptote here. This is perpendicular line, and the graph will be increasing like this one. It never meet with this line. That is the asymptote, and that is working as an asymptote. Right, this is a graph of, this is cosec x, and if you look this one here, and if you minus this one, that it will increasing to negative infinity, and this minus 5 by 6, it is minus 2. This is minus 2, and minus 5 by 4, it is lesser than minus, this is 1 by 4, and this is minus 1.15, and minus 5 by 2 is, this is 1, this one. And if look this one, the graph is drawn by free hand and like this one, that is rapidly increasing to this one. And just change this one, 1 2 3 and 4. This is minus 5. Here the minus 5 is minus infinity, and just draw the asymptote here. That is the asymptote. This is, oh sorry, line is not perpendicular. Just draw this one, this one. Okay, this is asymptote. This is asymptote here, and this asymptote, the value will be increasing. This is this one. It's moved like this one, and here again that is minus 5. This is minus infinity. This is the graph of this is the first quadrant, this is the fourth quadrant, and you can further this is in second quadrant, we have like this one, a negative, and second quadrant the cosec is negative. This would like this one, and the next is this is fourth quadrant. Then third quadrant, third quadrant it is also negative, negative, that one. You can draw this one graph, and then further now chart this one. It is very near to 0, that is tends to infinity, and the minimum value is 1, the minimum value. And then this is first quadrant, and then check it, the second quadrant, the value is again increasing to infinity, and at pi, that is pi at it is infinity, and it never meet this line. This is perpendicular to x-axis. That line is called asymptote. And here the same case, this is minus pi, and this is again that is asymptote, and this that means this line, the graph of this cosec x never meet with the y-axis. This is this axis, this line, that line is called asymptote. This line which we have drawn, this one, it never meet that line, that is asymptote. Here that is y-axis is behaving like asymptote in the for both the cases, like in the first quadrant and the fourth quadrant. It moves is on this one to infinity, and if very close to 0, the close to 0, that is very near to very near to this the infinity. That is the graph of the cosec x. Let's check it. This is now the try to draw the graph of secant x. Thank you, students. Thank you.